Welcome to the navigation training flight. I've engaged the autopilot to keep the aircraft level and on course, so please do not touch any input controls outside of the training commands you will receive. In this flight, we'll overview the navigation systems of the A-10C and practice navigation procedures. If you find it hard to hear my instructions over the background noise, exit the mission and turn down the world and in-cockpit sound sliders to about 50% in the options menu. Increase throttle to about 90% core RPM to keep the aircraft above 250 knots indicated.
Warning, autopilot.
The A-10C is equipped with a complex navigation suite consisting of a number of different systems. The oldest of these, originally installed on the A-10A, is the Heading Attitude Reference System, or HARS. HARS is a gyro platform navigation system and accumulates significant errors as the aircraft is maneuvered in flight. It can be reset accurately only in level flight and no acceleration. Because of these limitations, HARS is considered a backup system used in case of primary navigation system failure. The primary navigation system of the A-10C is the embedded GPS, INS, or EGI, often pronounced IGI. The IGI integrates a traditional inertial navigation system, INS, and a global positioning system, GPS. However, they are designed to work together to provide accurate worldwide position and flight navigation data. Finally, the A-10C is equipped to home on traditional radio navigation systems such as TACAN, Tactical Air Navigation, DCS, Instrument Landing System, and ADF, Automatic Direction Finder. The primary control panels used to configure the navigation systems include the Navigation Mode Select panel, NIMSIP, on the front dash, and the Control Display Unit, CDU, on the right console. In this mission, we'll also work with the TACAN panel on the right console. In order to minimize the time spent head down configuring the instruments instead of looking up and out of the cockpit, the A-10C features the upfront controller, UFC, below the HUD and the CDU repeater page on the MFCD. These allow you to manipulate CDU data without having to touch the CD. Navigation information is displayed to the pilot on the HUD, the TAD and CDU pages of the MFCD, the CDU display, and the analog ADI and HSI instruments on the front dash. Let's begin taking a more detailed look at each component of the navigation suite. The NIMSIP, located in front of the control stick toward the bottom of the front dash, is used to select the navigation system used to feed data to the instruments and what type of navigation points to home on. Specifically, the top row of select buttons selects between HARS, IGI, and TISL, Target Identification Set Laser. You will generally use the IGI as your primary navigation system, and you can see that it is selected by default. Like HARS, TISL is an A-10A legacy system that has been replaced on the A-10C by the AN/AAQ-28 Lighting 2 targeting pod. Along the bottom row of the NIMSIP are buttons to set the type of navigation points to home on. These include STR-PT, steer point, ANCHR, anchor point, TCN, TACAN beacon, and ILS, instrument landing system. During flight operations, you will usually navigate toward a steer point, so STR-PT will be the preferred selection. TACAN and ILS are used for airbase approaches and landing, and anchor point is usually the mission bullseye. In review, the selections of source navigation system on the top row and the type of navigation points on the bottom row determine which system provides steering information presented on the HUD, ADI, and HSI, and toward what type of navigation point. As well as the course warning flag on the ADI. The two homing lights to the right of the select buttons indicate VHF or UHF radio homing when either radio is used in ADF mode. Watch your speed. Stay above 250 knots indicated. The next item we will consider is the TAD page, currently displayed on the left MFCD. The TAD includes symbology for your aircraft, currently in the center of the display, a flight plan course line, currently running along the center from top to bottom, and various other indications, which we will discuss separately. To work with the TAD page, we need to set it as our sensor of interest, SOI. To do so, press and hold the HOTAS Coolie Hat left command or the H key on the keyboard. Alternatively, you can press the TAD OSB 15. When set as SOI, the display will become inscribed in green.